Hey folks, well, this time around I want to get into talking about the use of loops. So this is a different way of getting repetition to work, right? We've looked at how to do that with recursion, but we'll talk about why recursion is not always the best idea and look at a more efficient approach. And so there's two kind of basic control structures we'll look at for this idea of loops, of repeating code. And one of them is where we check a condition to see if we should do something again and again and again, and then do it. So check and see if we should do it, do whatever this block of code is, check again, do it again. The general idea is whether we test first and then do the block of code, or whether we do the block of code and then test to see if we should do it again. So we'll look at three specific C++ structures of loop. So we'll look at while loops, do while loops, and for loops. And we'll get into talking about why anything you can do with any of these, you can do with any of the others. So we'll talk about the equivalence of these types afterwards. And then we'll introduce a brand new layer of scoping, right? We've got global variables and local variables. Now we'll introduce stuff that only exists within loops. So that's the general idea of what I want to kind of get through here today. All right. So again, we introduced recursion as one way of getting repetition to work, but function calls themselves are a fairly expensive operation. There's a bunch that that has to take place behind the scenes to set up the function call, to transfer control back and forth, to set up the parameters and the local variables and that kind of thing. And you use a kind of an extra layer of memory every time you make an additional function call. So a lot of the recursive techniques we've looked at can get kind of expensive compared to other ways of doing things. So most languages provide an alternative means of repeating a particular block of code, and these are generally referred to as loops. Again, this is a much simpler structure without needing a function call to get the repetition going. So as I was saying a moment ago, the general idea is that we have some block of code we want to do 1 time or 10 times or maybe 0 times, but what we'll do is have some kind of a test either before the block of code or after the block of code. We'll call it a top tested loop if we test first and then go through the body of the loop and then come back to see if we need to do it again. Or we'll have another kind where we do the body of the loop once and then check to see if we should go back and do it again. So they're very, very similar logic. It's just a slight structural difference. So the sort of top tested versus bottom tested idea, again, is we've got some kind of a condition to check, do I need to do this loop or do I need to do it again? Do I need to do this block of code again? And so we can either test the block of code or test to see if we should test the condition and then execute the block of code if we need to, and then go back and do it again, and go back and do it again, go back and do it again. So just testing every time. Should I do it one more time? Do it. Should I do it one more time? Do it. And eventually, this test condition fails, and we decide, oh, okay, it's time to stop doing this block of code, and we go on with whatever the rest of the program is. And you can see where the loop gets its name. It's from this kind of cyclic structure we get going. And then the other idea is we do the block of code first, and then test afterwards, and see if we need to go back to the beginning and do the block of code again. So very similar ideas, it's just where the actual test condition is placed. So of the different kinds of loops that we'll play with, C++ has one called a while loop. So this is one of the top tested loops. And we'll have a Boolean expression that we check, a lot like with our if statements, where you're checking to see if something is true or false. And if the condition is false, then we'll skip past the loop. We won't do the block of code inside. We've decided that no repetition or no more repetition is needed. And it just goes on with the rest of the program. If the condition is true, then that means we do need to do the block of code. And so we'll go into the block of code, we'll do it, and then we'll come back to check again. So what we've got here is a little while loop that just says, okay, while x is less than y, do this stuff. So the syntax is the keyword while, the condition you want to check, and then the open and close brackets, and inside you'll have everything you want to do for that particular cycle of the repetition. So in this case, what we'll do is while x is less than y, print x and add 1 to x. So this guarantees that hopefully eventually x will be bigger than y and eventually this loop's going to stop. But it's going to go through this process of saying, okay, suppose y is 10 and x is 5. Then it'll come through and say, well, yeah, 5 is less than 10. Print 5, add 1 to it, so now x is 6, and go back and check again. 6 is still less than 10, do it again. 7 is still less than 10, do it again. So you're just cycling through the body of this thing over and over and over. And eventually, the condition is no longer true. Right? Eventually, x hits 10, for instance. And we say, okay, the condition's false, so we skip past the while loop and go on with the rest of the program. So while loops are probably our simplest loop structure, top tested. It's one that we'll use quite a bit. So here's just a quick example for a program that's going to count down from some integer value n to 1. So let's say we'll start off at n10. We want it to count down, display 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then quit and print done. So we start out, we declare our variable, we've got some initial value for it, and we'll say, okay, well, while n is greater than 0, so as long as it's 1 or bigger, what we'll do is print out the current value of n, and then subtract 1 from n to make sure that eventually, to make sure that the values are actually going down. All right, so this is going to go through, again, the first time 10 is bigger than 0, print 10, change n to 9, go back and check again. 9 is still bigger than 0, print 9, subtract 1 from it, go back and do it again. 8, still bigger than 0, 7, 6, 5, 4, 3, 2, 1 is still bigger than 0, so it prints the 1, subtracts 1 from it, and so now n is 0, and so this time when it goes back up here, 0 is not greater than 0, so we don't do the body of the loop. We drop out and we print our done. So yeah, this is the kind of general cycle that we're looking at for our loops. Let's just have a quick play with that. Let's see what we've got here. How about we just drop into some 160 experiments here, and let's create a simple loop. So we'll use our IOStream library this time around and our standard namespace, and we'll just put this in a main routine. You can put loops in functions or anything else you like. So let's do that same sort of an idea. So we'll go through and this time maybe let's go through and get the user to enter numbers until they enter something bigger than 10. So let's have a let's count how many tries it gets as well. So we'll have a count the number of tries that the user makes, and we'll have the integer value that the user actually enters. And so what we'll do is let's start the user value off with just 0, for instance. And so what we'll say is, while the user value is less than 10, let's prompt them to enter number 10 or bigger. I guess I should make that an integer. Enter an integer 10 or bigger. We'll read it in. And we'll update our count of the number of attempts that they've made. All right, so we'll just add 1 to it. And again, remember that plus plus notation is the same as count tries is equal to count tries plus 1. So this is going through and saying, all right, if the user value is less than 10, and in the beginning it's 0, so we know the first time through it's less than 10, give them their prompt, read in what they give us, add 1 to the number of attempts that they've made, and then go back and check again. So now we see, and here I'm not checking if cin fails, but assuming they do actually type in an integer, let's say they type in 1 or -7 or 9 or something like that, then this condition will still be false, right? The user value is still less than 10, so it'll do it again. Enter an integer 10 or bigger and read that new value in, add another one to the number of tries that we've made, and it'll just keep going through this until eventually they give you a value of, say, 10 or 20 or something like that. And then, we store the 10 or the 20, we add one to our number of attempts, and then this check will fail because 20 is actually bigger than 10, or 10 is equal to 10. And so at that point it'll drop out of the loop, and we can go through and print the correct answer was, and whatever they gave us, our user val, and we can say obtained after however many tries, after count tries attempts. So we can go through and compile this, and again, in theory, this should count up how many attempts it takes for me to actually give it a valid value. So let's try our compilation here. .cpp, let's turn on our error checking just in case I goofed anything in there, and we'll put this in a, I don't know, loop 1 executable. All right, so let's give this a try. And so we hit that first cycle through the while loop where it's prompting me to enter an integer. I'll type something in and it'll read that into our user val. And again, it's gone through and hopefully it's said, okay, well that was one more attempt, so I'll bump up the number of tries, and we go back. It says, well, 1's not bigger than 10, or 1's still less than 10, so let's try again. So we're in the body of the loop for the second time. Right, I enter, I don't know, -9. Still not good. Eventually I enter 12 or something like that, and it goes through and says, oh, okay, yeah, your final correct answer was 12, and you got it up after 3 attempts. So we can see this cycle where, we set up whatever information we need before the beginning of the loop, have our test to see if we need to get into the loop the first time around, and in this case we certainly do. And then each time through, we just go through all of the actions inside the body of the loop, and then go back to the top and test again. See if we need to do it again or if we're done. And that's the idea for our loop structure. All right. So that's the while loop, our top tested loop. We've got a do while loop that's a similar idea but bottom tested. So the syntax looks a little bit different because we're going to have to kind of wrap the top and the bottom here. But it's going to go through, do the body of the loop, and then when it hits the bottom, it's going to look at some condition. If the condition is true, then we'll go back and do the whole loop again. And if the condition's false, we'll drop out. So in this particular case here, we've got the syntax for a do while loop. So we've got the do, the body of the loop, and then the while and whatever our condition is. And so this one's going to go through and say, okay, we'll print out x and add 1 to x while x is still less than y. So again, let's say x started off at 5 or something like that. Then it's going to print the 5, add 1. So now x is 6. Is 6 less than 10? Yeah, we'll go back and do it again. So whatever this cycle is, it's going to go through the same sort of process. The big difference between a while loop and a do while loop is that you're always guaranteed to go through the body of the do while loop at least once. Right? With the while loop, the condition could have been false that very first time. Right? Suppose in this example back here, we'd started n at, I don't know, -10 or something. Then it would have failed that very first test, and it would have jumped straight to the bottom and just said done. Right? So with a while loop, it's possible you'll never execute the inside of the loop, whereas with a do while, you're guaranteed to do it at least once, right? Because you execute it once before you ever check to see if you should do it again. So do while loops, very similar idea, just that one structural difference. Anything you can do with a while loop, you can do with a do while loop, and vice versa. Just needs a bit of tweaking to get the starting and stopping conditions right, if you like. So one of the places where we use do whiles a lot are cases where we want to get a value from a user or from another program maybe, and we want to check if it's valid and then keep going back until something is valid. So we always want to do that at least once because we want to get that first value from the user. So this is a pretty typical use of a do while loop where we'll say, okay, well, enter a positive integer, read it in, and if what they entered wasn't a positive integer, we want to go back and do it again. So essentially we've got an error check here. While the user value is still too small, go back and do it again. So every time we go through the loop, we say enter a positive integer, read it in, and then check to see if we need to go back and do it again. And cycle through this over and over and over until eventually they give us a positive integer and we bail out. Now, of course, we're not, in this example, I haven't checked cin.fail, but just as a kind of basic example of a do while, this is pretty typical. Now, if we want to get a little fancier and throw in our error checking to see if they entered something that wasn't an integer, and if so, then flush the input buffer. And if they entered something that was an integer, we still need to check and make sure it was big enough. And if it wasn't, we need to get them to try again. And otherwise, we can say, okay, well, you've given me an integer and it's big enough, we can quit now. So what I'm going to do is throw in a Boolean variable to keep track of whether the value that we just read was good or not. So we'll attempt to read in a value, and then we'll set that variable to either true or false, and depending on whether it's going to be a good value or a bad value. And then the loop condition at the bottom just needs to look at that variable and say, okay, well, does the variable tell me it was a good value or a bad value? So this is the idea that we're going to go with. And again, this time we'll throw in the error checking for non-integers and that kind of thing. So we've got the kind of, since this is intended to be one big program here, or at least one big chunk of code. So we've got the variable for our user value, so we want to get an integer from them, and we'll have this Boolean variable for bad value. So I'm going to set this to true if they gave me bad data and I have to come back and do it again. And I'll set it to false if they gave me good data, and so I can leave and go on with the rest of the program. So if we ignore everything else for just a moment, you see our do and our while bad value. So this is saying while bad value is true, go back and do it again. And then inside, we want to set the bad value to true if they gave me bad values, and set it to false if they gave me good values. So inside, we'll read in the value from the prompt the user, read it in, and do our error checking. So we've got that first step where we'll go through and say, okay, give me a positive integer, and we'll attempt to read it in. Now, we always want to check first whether that cin actually worked or not. If cin didn't work, then user val basically contains garbage because cin couldn't put anything in it. So you always check to see if cin failed first. If cin failed, we'll deal with that. If it didn't fail, then we can go on and look at what's in user val. So if cin failed, then it is a bad value because it was something that wasn't an integer. So we'll do our cin.clear to get rid of that error setting, and we'll do our cin.ignore to flush the input buffer, kind of get rid of whatever garbage is sitting there that cin couldn't read. And if that's the case, then we could give them an error message that wasn't an integer, and we'll prompt them to try again. So that's our case for a failure on the input attempt. Otherwise, so our else case here is to say, well, otherwise if it was an integer but it was too small, we still want to get them to try again, but we don't need to flush the input buffer. So if the user value was simply too small, we did read it in, it's still a bad value, so we'll set bad value to true, and we'll still tell them to try again. But again, we don't need to flush the input buffer because cin actually worked, it actually read the value. It just wasn't a value that we want to use. And finally, the general case where they actually gave us something we can work with. So in this case, we'll set bad value to false. The data's okay. And that way we've got our, check for the first kind of error, check for the second kind of error, otherwise it's okay. And again, our while condition is saying, well, just keep going back and doing this again and again and again, as long as what we've got right now is a bad value. And then eventually we leave and print out the user value at the end. So this is a very common format for trying to get a value from the user, doing your error checking, right? See if we managed to read something in, If we manage to read something in, see if it's valid, and proceed from there. So, pretty common format for a do while. All right, the third kind of loop that we're going to look at has a little bit fancier control structure. It's going to try and group all of the kind of control-related information into one spot in the for loop. So this is a top-tested loop, and the control statement for the for loop has three chunks to it. It's got one chunk where we initialize the variable we're going to be working with, one chunk for the condition that we're going to be testing kind of at the top of each pass, and one spot for how we're going to update our variable at the end of each pass through the loop. So we'll have these three chunks, and they're going to be separated by semicolons. We'll do the syntax in just a second here. So whatever our initialization statement is, it does that once at the beginning, and then dives into checking the loop and doing the body. So top tested for the condition check, and again, if the condition is true, do the body, and then come back and check again. Whatever our update statement is gets performed as kind of the last action in the body of the loop. So we're just kind of restructuring where stuff sits in our code. And we'll take a look at an example here. So this is a simple for loop, so we're going to count from 0 to 20 by 2s. So 0, 2, 4, etc., 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 up to 20. So I'm going to declare my variable first, and then my for loop has these three parts in the statement. And again, you can see that those three parts are separated by these two semicolons inside. So the first part is where we'll initialize x. So we'll set x to 0. And again, the for loop's going to do that once at the beginning. We'll have our test that says keep going while x is less than or equal to 20. And then we'll have our update statement that says at the end of the body of the loop on each pass, add 2 to x. And then inside, we just have whatever we want to do with x while the loop is running. So in this case, it's going to start x off at 0. It's going to print x. Well, it's going to test 0 is less than 20, less than or equal to 20. Print x, add 2 to x. Go back and see if 2 is still less than or equal to 20. Print the 2, add 2 more. So now it's 4. Is 4 less than or equal to 20? Print 4. Add 2 to it is 6 less than or equal to 20. So it's just going through this cycle. And effectively, as far as the compiler is concerned, this acts just like having that x equals 0 at the beginning, and then our while x is less than or equal to 20, and then whatever's in the body of the loop, as many statements as you like, and then that update statement as the last thing inside the body of the loop. So these two things are essentially exactly the same structure in terms of behavior. And then again, once we get out of the loop, we print our done. So it's just a different syntax for kind of writing the same information. And the advantage for the for loop is that it gives you the three pieces of information you're interested in all in that one spot, right? It tells you how it's initialized, it tells you what the condition check is, and it tells you how the information is getting updated on each pass through the loop. So in some ways that's a little clearer for the programmer, depending on how complex these conditions actually are. So this quite often gets used in where you're dealing with some kind of counted sequence of values. You're going up by 1s, you're going up by 2s, or maybe if you're doubling the value every time through, where you've got a kind of a clear starting point, a clear stopping point, and a very clear way to update the values each time through. A for loop is a pretty common approach. Now, the three different kinds of loops are equivalent in terms of their capabilities. Anything you can do with one of the kinds of loops, you can do with either of the other two. It's really just a question of which one seems to fit the best for the way you want to use it right now. Which one's going to be the clearest or the easiest, or again, or just which one you actually prefer. So as far as the course goes, certainly there'll be times in quizzes or the exam where I say, you've got to use a for loop to do this, or you've got to use a while loop to do this, just to make sure that you do actually understand the syntax for them and you can use them appropriately. But in general, when you're writing code, you'll pick whichever one is the most suitable for what you're trying to do. So again, we've seen a couple of examples here. For loops quite often get used when you're doing some kind of counting up, counting down, and processing some sequence of values. The do whiles are often used for getting and checking input. The whiles are often used when you've got perhaps a more involved stopping condition that you want to check and that you're trying to test. But any of the three loop types can be used in pretty much any circumstances. Now, we now encounter a new variable scope. So we've already seen global variables where they're visible throughout the entire program, right inside all of the functions, inside the main routine, from kind of the point where you declare the variable on. And we've seen variables that are local to a function, variables that only exist within the function that they're declared in. But now we're going to add a new layer, variables that are local to a loop, that are only visible in the loop that they're declared in. So if you declare a variable inside the body of a loop, that's the only place you can see it. It only exists inside that loop. Right? Once you hit the closing bracket to end that loop, that variable is no longer visible. So again, just as a quick example, here we've got variable x, right, declared before the loop. So it's, let's say this is in a function someplace. This is going to be local to the function and visible throughout the function. So it'll be visible here, it'll be visible inside the loop, it'll be visible after the loop. And then the body of our loop, so we're going through, I guess, for values 5 through 9, for instance, or, ooh, this is an infinite loop. There's no update to x. Okay. This is going through and saying, okay, well, while x is less than 10, we'll have a local variable y, and we'll prompt the user to give us an integer, and we'll store it in y. So this y only exists inside the loop. And so what we're doing is, getting a new value for y from the user, and then printing out the current value of x times y. And then go back and do it again and see if x is still less than 10. Now in this particular case, x is always going to be less than 10 because I forgot to stick in a statement to change the value of x. So this is what's called an infinite loop. This is where Control-C comes in handy when you're running your programs. So if you're on Linux and you're running your program and it goes into one of these infinite loops where it can never stop because there's nothing in the body of the loop that will ever change x to be a value that will stop this condition, then just hit Control-C and the program will get killed and you're back at your Linux prompt. So this is one such example, but that wasn't what I meant to get into. The idea is this y variable is local to the loop. It only exists inside the body of that loop. So once we get out here, once the loop ends, there's no way for you to access whatever y was inside the loop. It's gone. Right? It's no longer accessible. So that is kind of one additional layer of scoping to think about. One place I wanted to explicitly mention that's an example of this is with do-while loops. So in this case, I'm going to have a loop that's getting values from the user, and we want to keep going until they give me something that's 1 or bigger. Keep getting integers from the user. Now I'm not doing my cin.fail tests here just to keep the example compact, but we'll have our do-while loop. We'll have our integer variable y again. Maybe we prompt the user, please enter an integer bigger than 0. And we read it in, store it in y. And then what we wanted to do was to keep going as long as y is less than 1. So if they give me a 0 or a negative number, I want to do it again, and again, and again, and again, until they give me something positive. The problem is that, again, that y is local to the loop. So it only exists from the point where you declare it up until that closing bracket that ends the body of the loop. It's not visible in the test condition here. So if you try and compile this, the compiler is going to yell at you and say, nope, can't do that. Y doesn't exist in this scope. And again, it's precisely because you declared y inside the body of the loop. So if you really do want a test condition like this, if you want your test condition to be able to look at y, then you need to declare y before the loop starts. So above the do, for instance, do your int y, and then do, in your open bracket. So that is something that we'll certainly run across. It's not an uncommon error, but just one to watch for. All right, next time we'll get into more advanced control of loops, and we'll get into nested loops, putting loops inside loops. But we'll save that for next time.